Hey guys, welcome back. I hope everyone had an opportunity to watch the introduction to applications of differentiation. And if you have a calculus book, this will be chapter 3, and we are now on section 1. So, this section is called extrema on an interval. And first, we are going to have to start off with a definition, okay? So, the definition of a critical number. What is a critical number? Well, imagine you have a function called f, okay? And if there is some place C such that the derivative is equal to 0 or the derivative is not defined, okay? So it's not differentiable. So it's either the derivative is equal to 0 or the derivative is undefined, then what we call C is a critical number, okay? So we need to know this critical number in order to help us find relative extremas. Now, extrema is basically what I discussed in the first video in the introduction, which is relative max and relative min. So let's discuss a few more about this critical number and why it's so important. So once again, a critical number is where the derivative is equal to 0 or where the derivative is undefined. And now I'm going to show you why it's so important. So I have these graphs here, and imagine I have something like f of x is equal to, let's say, x to the third minus 3x squared. So this graph here has a y and an x-intercept as 0, 0, so it looks like this, and it cuts through one more time for another root, but that's okay. At 0, 0, I'm going to change the color. At 0, 0, there is a maximum, okay? We call it a relative max. And at 2, negative 4, okay, because I did this problem already, there is a minimum, okay? If you take a look at the slope at x equals 0, the slope is the slope is 0. And if you take a look at the slope at 2, negative 4, the slope is also 0. Now, at x equals 2, the slope is 0. At x equals 0, the slope is 0, okay? So what I was referring to in this example here by that C in this case, there's two of them. One of them is 0 and one of them is 2. And in both of these cases, the derivative is equal to 0, which means the slope is 0. So let's try another example now. Okay, so let's say that you have, can I erase this? Of course I could. Okay, so let's pretend that you guys had the absolute value. Let me change the color. The absolute value, which is f of x is equal to absolute value of x. Well, actually, this will have a minimum at 0, 0. But I'll show you later, I guess, why f prime of 0, in other words, the derivative at 0, actually does not exist. And basically, any sharp turns that we have, I'm sure you heard in other videos, any sharp turns that you have, like when it goes like that and then a sharp turn, the derivative is not defined. In other words, it's not differentiable at x equals 0. Okay, another example let's just say we have the sine curve. So the sine curve looks like this, right? And if you remember, sine has a high value of 1, right? Y equals sine x has an amplitude of 1. It'll never be higher than 1. And so that's at pi over 2. So right now, there's a maximum at x equals pi over 2. And there's actually a minimum at x equals 3 pi over 2, which is this number right here. And if you take a look at the slope at pi over 2, it's 0. And if you take a look at the slope at 3 pi over 2, it's 0. Therefore, f prime of pi over 2 is equal to 0, and f prime of 3 pi over 2 is equal to 0. Therefore, pi over 2 and 3 pi over 2 are what we call critical numbers. So a critical number is where the derivative is equal to 0. Okay? So you might have something that basically increases and then slowly decreases? Well, there might be a slope of 0 somewhere around here, and that would be a critical number. So a critical number is where the derivative is equal to 0. So let's try 2 quick examples, okay? Oh, this one first. What is the critical number for this parabola? Well, all you have to do is take the derivative first. That's 2x minus 4. Everybody got to make sure that they know how to take a derivative. Second step is to set it equal to 0. You want to see where the derivative is equal to 0. Then we're going to solve for that x. So you're going to add 4 and then divide by 2. Therefore, a critical number is at x equals 2. Okay? That means that there may or may not be a maximum or minimum value there. There may or may not be a max or min, but this is great because we must check. Okay, in our next video, we will discuss if 2 is a max or a min, okay? Or neither. Let's try one more because this video is only on finding critical numbers. F prime of x is equal to 12x to the third minus 12x squared. I'm setting the derivative equal to 0, and then I'm going to solve. I have to factor out a 12, factor out an x squared, and then I'm going to have an x minus 1. So x equals 0 and x equals 1, because you guys know how to solve for this, right? So you go like this, and you set each piece equal to 0, and you get x equals 0 and x equals 1. So therefore, the critical numbers are 0 and 1. Okay? So critical numbers are where the derivative is equal to 0 or the derivative is undefined.